Parameterize the circle, or write the parametric equations for the circle that is centered at the origin, has radius 2, starts at the positive y-axis, and has a path that rotates in the clockwise direction. To begin, remember we can define the unit circle as x equals cosine theta and y equals sine theta, and if theta goes from 0 to 2 pi, the point would start at 1, 0 and rotate counterclockwise. If we want functions of t, we can say that x of t equals cosine t and y of t equals sine t. It's also helpful to recognize the graph of the basic sine and cosine functions shown above. And now let's see if we can find the circle that we want, which again is centered at the origin, has radius 2, starts at the point 0, 2, or the positive y-axis, and then rotates clockwise. Going to Desmos, to enter the parametric equations for the unit circle, we enter open parenthesis cosine t, sine t, and the interval for t will be from 0 to 2 pi. And notice we do have the unit circle shown on the right. And now let's trace out a point along the unit circle from t equals 0 to 2 pi. To do this, we'll go to cell 2 and enter the ordered pair cosine a, sine a, and click Add Slider, and we'll have t go from 0 to 2 pi, and we'll have the step be pi divided by 16. Click out of cell 3, let's drag the slider back to 0, and let's click Add Label. Notice when the angle is 0 radians, the point is 1, 0, and as t increases to 2 pi, the unit circle is traced in the counterclockwise direction. So again, our goal is to find the parametric equations for a circle centered at the origin with a radius of 2. We want the point to start at 0, 2, or along the positive y-axis, and rotate clockwise. To begin, for a circle with radius 2, we would have x equals 2 cosine t and y equals 2 sine t. Let's also change the point to 2 cosine a and 2 sine a. So now we have the correct circle, but the orientation is not correct because right now the point starts at 2, 0 and rotates counterclockwise. So going back to the initial point, if we want the first point to be 0, 2, not 2, 0, we simply need to interchange the x and y values. So let's go to the black point and let the x value be 2 sine a and the y value be 2 cosine a. Notice now when t equals 0, the point does start along the positive y-axis or at the point 0, 2. And notice as t increases from 0, the sine function value or x will increase, and the cosine function value or y will decrease, which will give us a clockwise orientation. Notice as t increases from 0, the point now does rotate in the clockwise direction, and all conditions have been met. So the parametric equations are x of t equals 2 sine t, and y of t equals 2 cosine t, and t would have to be on the interval from 0 to 2 pi. Notice I did not include 2 pi in the interval simply because the sine and cosine function values at 0 radians and 2 pi radians would be the same. So over this interval, the circle is traced out exactly one time. I hope you found this helpful.